Hello everyone, welcome to this lecture. In this lecture I am going to talk about the multiplexers. So this is a very well-known term. First I will talk about few of the properties of multiplexers and then we will discuss it in detail. So let's see it. In short, multiplexers are also known as mux. So we also call them mux. Now there are different types of mux. So what is a multiplexer? Let's see it first. A multiplexer or mux is an electronic switch that can connect one output out of n inputs to the output line. So we assume that there is a circuit. Let me draw like this. So let's say it is a mux and I'm assuming, let's say 2 cross 1 mux. So this is a 2 cross 1 mux. Now what happens? There are multiple inputs and there is only single output. So these inputs, let's say this is, I'm assuming I0 input 0 and this is I1 input. These input need to be switched to this output and that is the role of the mux only, right? So the switching will be done something like this based on some select lines. So these inputs will be switched to the output based on the select line. So there will be select lines. In case there are two inputs, there will be only one select line. So how do we calculate the select lines? Later on we will see. So this is 2 cross 1 mux. Okay. So it is a kind of switching circuit which transfers the input line to the output. There is only single output but multiple inputs. At a time only one input will be connected to the output. Now it cannot change the logical level. So whatever the input we are passing, it does not change the input. If I0 is 0, it will pass only 0. If I0 is 1, then it will transfer only 1 and so on. If based on this select line, if this I1 is being transferred, at a time only one input can be transferred, then it will transfer the value of I1 as it is. It does not change the logical level, right? It only provides the connection between it. It is a functionally complete. So in one of my previous lecture, we have talked about the functional completeness of any circuit. The meaning is, if a circuit is functionally complete, it can be utilized to realize any kind of circuit. Like NAND gate is universal gate because NAND is functionally complete. Similarly, NOR is universal gate because NOR is functionally complete. So similarly, mux are also functionally complete. They can also be utilized like NAND and NOR to realize any kind of circuit. Then let's say the select lines are used to pick one among the inputs and switch as output. So the select line, which I have considered here as S, this is responsible for picking one input out of n, right? Now if we have, let's say 2 to the power n cross 1 mux, then in that case there will be n select lines. So the number of select lines, how we will find out, if there are n number of inputs, let's say, or you are saying 2 to the power n inputs are there, output will always be 1 in case of mux. Output will always be 1, 2 to the power n input. So in order to decide the select lines, we need to take the log of it. We can take on base 2 log of 2 to the power n. So this will give us n. So because n will come out based on the log property, and it will become log of 2 base 2. So 2 base 2 will give us 1. That means there are n select lines required based on the 2 to the power n inputs. So similarly, we have written n select lines here. If there are 2 to the power n inputs, right? Now let's try to identify the behavior of mux in detail. There are different types of multiplexers available. So the very first category, the 2 cross 1 mux, we have. We also have 4 cross 1 mux. Input will always be in 2 to the powers. So we can have 8 cross 1 mux. We may have 16 cross 1 mux. Dot 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 2 to the power n cross 1. Now based on the inputs, we will decide the select lines. So if I draw like a table, how we can decide the number of select lines. So if there is 2 cross 1 mux is there, and we are deciding the select line, what will be the count of select lines in this case? Okay, so as I told you, you just take the log of it, and if you take log of 2 base 2, it will give you 1 only. So you can take log of 2 base 2, that will give you 1, so there will be only one select line. Now in the second case, 4 cross 1 mux, if we take the log of 4 base 2, it will give us 2, so there will be 2 select lines, and so on. Finally, when we are having this 2 to the power n cross 1 mux, we can take the log of 2 to the power n base 2, it will give us n. So there will be further calculation, right? So you can write for this 8, and you can also write for 16, and here I'm writing dot dot dot. So this is log, this is log of 8 base 2, that will give us 3. Similarly, log of 16 base 2 will give us 4, and so on, right? So how to find out the select lines? Here I am writing types of mux, type of mux, right? And these are the number of select lines. Now if we draw the truth table for any mux like 2 cross 1 or 4 cross 1 or 8 cross 1, how it will look like? Let's try to draw it. So let me clear this. So let's say I'm having a 2 cross 1 mux. So we can draw like a box. So let's say this is, and like this we can draw like a rectangular box also, but because there are a large number of more number of inputs than output, so we can draw the circuit like this, the box block diagram like this, and there is one in. Now based on the inputs, we will have one select line. Let's say select line I am representing like S. This is the select line, and there will be one enable or disable line also, you can say. So let's say this is enable line, which will enable this particular circuit. So this is for enabling. This is input, let's say I0, and this is input I1, and here we are getting the final outcome. Outcome can be either I0 or I1 based on the value of S. So if we are deciding it, I can draw the truth table like this for the same circuit. So the value of Y will be decided by based on, let's say there is enable line and there is select line S and there is Y. I0 and I2 are inputs. So if enable line is 0, that means this circuit is not enabled. So this S becomes, don't care, whatever the value S will have, either 0 or 1, this Y will always give us 0 because the circuit is not enabled, so we will not get. But in case this circuit is enabled and this E is having value 1, in that case, when this is enabled, in case S is having value 0, when S is having value 0, it will select I0, the very first input. Second case, in case the circuit is enabled but this S is having value 1, in that case it will select second input, that is I1, right? So based on this, if we try to write down the Boolean expression of Y, so how we can write it? Y can be 0 for this, so if Y is not available here, we need not write anything, but for this we can write it. So this is, you can write E when E is there, so you write E S bar, and this is, you are getting I0, or you can write this E S, S is the select line, and you are getting I1. So this is possibly, you can remember as the final expression for 2 cross 1 mux, where there is only one select line like S I have taken. You can take S0 or any name, and there are two inputs and one is enable line. Now if we want to realize this circuit, it is very easy to realize, it is not very difficult. So we can draw it. We need to have enable line, we need to have select line, and we need to have inputs. So there are two inputs, so you can draw the input. So let's say I'm drawing the input like this. So there is an input, like this is an input, there's another input, let's say you are taking, I'm taking, this is another input. So this is, let's say I0, this is I1. Now we are having a select line. So select line we can have like this. There's a select line here, and enable also, you can have an enable line also. So let's say I'm taking E here as well. Okay, you can take E here, or so this is, let's say I'm saying this is S and this is E, right? Now because there are dots in between here, if you find out, we need to use AND gates. right? And finally we will use OR gate, so the circuit can be completed. So let me draw it. If I have an AND gate here, like I am having an AND gate here, so I draw an AND gate here, and one more AND gate, let's say I'm having here. Okay, so we are having two AND gates like this. This is another AND gate we are having like this. Now let's make the connection. So E is enabled. If it is complemented, we are not representing that. So E we are passing from here, like we can directly connect. So E is connected here. Similarly, we try to connect E here. Without E, the circuit will not be active. So E is connected. And then, so if we are connecting S bar, we need to have S complemented way. So let's take the S as complemented form. So I am drawing one line here which will represent S as complemented way. Let's say this is, and here we are having a NOT gate. We are having NOT like this. So this NOT will give us S bar, right? Now, so in this we want to connect S bar I0. S bar is here. We connect S bar from here like this, and then we need to connect I0. So I0 is here. So we can connect I0 from here, right? And then we will get the output here from this AND gate. Similarly, in this another AND gate, we connect E. So E is already connected. Then S is here somewhere. So we can connect this S. Then we need to connect I1, and I1 is here. So we can connect this I1 like this, and then we will get the output here. Now after these two outputs, and once we get, we can use one OR gate, and in that way we can realize the function of mux 2 cross 1, right? So this is the 2 cross 1 mux function. One more thing we can do, rather than connecting this enable here, we can apply AND gate with this output. So let's say if this is expression, I can write y is equal to S bar I0 plus S I1, and I can take dot E. So in that case, this enable line we will not connect in these AND gate. Whatever output is coming, we can apply an AND gate and pass this enable line to that. So let's say this is, finally you are getting Y, right here. This is your Y, right? Similarly, we can realize the circuit for 3 input, or you can say 4 cross 1, not 3. So let's draw for 4 cross 1. So the circuit will be same, all these things will be same. Let me change these things. So what will be the changes here? There'll be 4 inputs. So let's say I0, I1, I2 and I3. There are 4 inputs I am taking, and these 4 inputs will be like I0, I1, I2 and I3. Okay, when there are 4 inputs, the select line will be 2. So there will be 2 select lines. So this is another select line. I can draw an like arrow if you want. Okay, so these 2 select lines, now we need to number them. So let's say this is S0 and this is S1 select line. Enable line is only 1, enable button, whatever you say. So once you off it, the circuit will be off and it has to be on, right? So this is 4 cross 1 mux multiplexer. In 4 cross 1 mux, we will have the similar kind of thing, but there will be more options available, right? So what we will have here, if with the similar fashion which we have in the previous, instead of S, we will have 2, S0 and S1. So let me clear it and then we can write the Boolean expression for that. Why? So like here we have, this is S0 and this is S1, and here we are having, let's say, Y, right? So what is happening here? For E is equal to 0, this S will become don't care. So that's for sure. This is don't care and Y will give you 0 only, right? Because if circuit is not enabled, we will not get any output, right? But in case circuit is enabled and we are having 4 inputs, so based on the value of S0 and S1, the output will be connected. So S0 may have, S0 and S1 can have possibly 4 combinations. So both can be 0, 0, 0, or it can be 0, 1. Then let's say E is 1, but it is having 1, 0. And let's say this enable line is 1 and both S0 and S1 are 1 only. So when both the lines are 0, we will get I0 as output. So I0 will be connected to the output line. Similarly, when S0 is 0 and S1 is 1, then we will get I1 as output. When we are having 1, 0 combination, then we will get I2, and similarly here we will get I3. So this is not very difficult to understand. Now once we get it, we can write the Boolean expression for Y. So let me clear this and let's write it. So what is the Boolean expression for Y? When we are getting this combination, so we can have like E dot, this is S0 complement, S1 complement, and you are getting I1, either this I0, not I1. Similarly, you can have E, this is S0 complement, and this is S1, and then you are having I1 here. Similarly, enable line is 1 here and S0 is 1, let's say, okay, and you can write it like S1 here, S0 here, it depends. So I have written like this, you try to understand in that way. So if I am having S0 here and S1 is complement, then in that case you will get I2. And if you have another combination like the last one where S0 and S1 both are available without complement, then we will get I3. So this thing is not very difficult to understand. Please don't get confused in S0 and S1. You can take, if you are considering this is deciding the LSB side, then S0 you can take here and S1 you can take here, right? In that case, all these things you just replace S0 and S1 and you will get this expression. So please do remember this Boolean expression for 4 cross 1 mux, right? The circuit we can write here, we can create the circuit similarly, but here we will require 4 NAND gate and we require finally OR gate also. So all those outputs of NAND we can pass to the OR gate and we can get it with similar thing. So we have 4 NAND gate and all those will come to the same OR gate and we can have that, right? So I think I need not to draw that. Let me write it for 8 cross 1 also. So I'm just cleaning it. So once you will be clear for, so now we are having, let's say 8 cross 1 mux. Now in 8 cross 1 mux, there are 8 inputs and 1 output. So let's realize the thing, how the circuit is working. So you are having like this and the output here. And you are having in this way. This is connected like this. Okay. There are inputs. So let's say 1, 2, 3, 4, 5, 6, 7 and 8. There is single output like this. Now 8 cross 1 mux it is. So this is, you assume that there will be I0, I1. You can number from top to bottom or bottom to top manner. I3, I4, I5, I6 and I7. The last one is the I7. Now we are having select lines. So how many select lines? Because we are having 8 input, we take log of 8 on base 2, we will get 3. So there will be 3 select line. Enable line will always be there. So there's enable line. So let's say I'm saying this is enabling the circuit. And there are, let's say S0, S1 and S2. So there are 3 select lines. Try to write in the truth table in the same sequence to avoid this confusion. Okay. So if I draw the truth table like this, first there will be enable line. Then let's say S2, then S1, then S0, and then we will have final Y output. So it is like this. Now this is, let's say, enabling the function. So this is E. Now after that, this is, let's say, S2, S1, S0, and this is Y. Okay. So if it is 0, it doesn't affect what is the value of S0, S1, S2. Final output will be 0 only. So that's for sure. Now if E is 1, there'll be 8 combinations of these S0, S1 and S2. So the very first, like 0, 0, 0, 0, 1, 1, 1, 1. Similarly here 0, 0, 1, 1, 0, 0, 1, 1. Here we will have 0, 1, 0, 1, 0, 1, 0, 1. Right? Now if we look at the output Y, when all three zeros are there, then we will get here I0. This enable line is 1 for all these rows. So this is 1 only, this is 1 only, this is 1 only. Right? Now here we will get I1, here we will get I2, then I3, then I4, then I5, I6, and finally we will get I7. Now if we write the expression, Boolean expression for this Y, so what will be the Boolean expression for Y? We can write it like we are getting all these bars along with E. So let me take E as common because E will come in all the functions. So I'm just taking it. And then I'm writing S2 bar, S1 bar, S0 bar, I0 plus. Again S2 bar, S1 bar, but S0 is not complemented. Then I1 will be connected. Then if we have S2 bar, so this we have considered, this we have considered. Now we are at this 2. So here S1 is not complemented, but S0 is complemented, right? I2. Now similarly here, the next we are having here. So S2 is complemented, but S1 and S0 are not complemented. Here we will get I3. Or now we reach to this place. So this is S2 is not complemented, but S1 and S0 both are complemented, and we are getting here I4. Then I5. So S2 is not complemented. This S1 is complemented, but S0 is not complemented. Then we are getting I5. Similarly, we will get this I6 when we are having S2, S1, but S0 is complemented, I6. And then the last term I7, we know that S2, S1, S0, and we will get I7. So this is the expression, right, we have as Boolean expression for this. So please do remember this expression. So let me highlight this thing. So it is very easy to write the Boolean expression for any kind of mux. Okay, so I have discussed 2 cross 1, 4 cross 1 and 8 cross 1 multiplexers in this lecture. So this is sufficient for the lecture, this lecture. In next lecture we'll be talking about demultiplexers. Thank you.